All right, today's lesson, guys, we're going to use synthetic division to evaluate functions as well as prove that factors are either part of the polynomial function or are factors of that polynomial function, or they are not. The remainder theorem. If you want to evaluate a function at a given x value, use synthetic substitution. So if you know what we did yesterday, we did synthetic division. We're essentially going to do the same thing, only now we're substituting in a number to evaluate that specific function at that x value. So real quick, remember that evaluate is terminology that means plug in. Okay, so it says evaluate f of x at x equals -3. Well, if you saw this, guys, this is something from, algebra, intermediate algebra. You're just going to plug 3 in everywhere you see x. And if you did that, you'd get -3 to the fourth minus 10 to the, 10 times -3 to the second minus 2 times -3 plus 4. Sorry, I had to cough there for a second, but I did some math as well. So I evaluated that. Now all I have to do is use order of operations moving left to right. So 81 minus 90 is -9 plus 6 plus 4. So that's -3 plus 4. So the answer is 1. So at the x value of -3, you get out 1, right? If the input is -3, the output is 1. So that's one way to do this. Another way to potentially do this is to use what we call synthetic substitution. And all you're going to do is literally use synthetic division, and whatever you get for the remainder, that is what you would get if you were to plug that number back into the function. Okay, so if we were to use synthetic substitution, again, the solution, or this number right here, goes in that half box. So you got -3, then the coefficients. So that's 1. We need a placeholder because it's not x to the third, so that's 0, -10, -2, and 4. Okay? Bring down the 1, so -3 times 1 is -3. Add those, that's -3. That's 9, that's -1. That's 3, that's 1. That's -3. And then the remainder here is 1. And holy cow, so this is the remainder. And is that exactly what we got here when we evaluated that function at -3? It is, right? So the remainder is also the output at that specific x value. So they are the same. So you can do one of two things. You can plug the number in for x and solve it, or evaluate it, or you can use what we call synthetic substitution, and the remainder is your answer at that specific x value. Can you please pause the video, use synthetic substitution, and see what you get for problem number 2. All right, real quick, if we were to use synthetic substitution, the remainder is 34. If we were to evaluate it the normal way, it's 34. So again, some of you guys probably think that synthetic substitution is way more efficient than plugging it in and multiplying that stuff out and using order of operations. You're more than welcome to use synthetic substitution to evaluate any function at any time, okay? Let's do the last one, and then we'll move on to something else. All right, last one here. If we were to plug it in, we would get 3. If we were to use synthetic substitution and look at the remainder, we would also get 3 again. I don't necessarily care which one you do, but do you guys agree that synthetic substitution is way more efficient than plugging it in, trying to evaluate fractions, that sort of thing? So I would strongly encourage you, if at any time, I would maybe use synthetic substitution because it is way, way more efficient. All right. The second thing that we're going to talk about today is the factor theorem. Okay, and the factor theorem states that if there is no remainder after dividing the function by k, then the polynomial x minus k is a factor. That should make sense, right? Like if you think about what we did yesterday, we took a polynomial and divided it by a factor, right? And if you take a number, let's say 20, and divide it by 4, and you get 5, right? Because 4 goes into 20 evenly, right? There is no remainder, then you know 4 is a factor of 20. We're essentially doing the exact same thing. We're just doing it at a more abstract level, okay? So if we look at this first example, it says given the factor x minus 2 given x minus 2 is a factor of p of x, factor the entire function completely. So in this particular example, it says that x minus 2 is a factor of that polynomial. So again, if we try to relate this to something you guys already know, it's essentially saying, given that 4, let's say, given that 4 is a factor of 36, factor the entire number, essentially is what it's saying, right? Well, if you didn't know what the other factors of 36 were, could you divide them? Yeah. So you could divide 36 by 4, you would get 9, right? So then you know the other two factors of 36 are 3 and 3. Does that make sense? Okay, so we are literally doing that exact thing, which hopefully for all of you seems doable, right? It brings you back to the days when you were in elementary school and we all loved math because there were no variables involved, right? So we're doing the exact same thing we just did here in this particular example, only now we're doing it at a little bit more abstract level with variables, specifically with polynomials. So given that x minus 2 is a factor, we want to factor the entire thing completely. Well, if I know that x minus 2 is a factor, do you agree that I could potentially factor out the x minus 2, so then the thing I'm left with, I potentially could factor, right? So let's do that. I know that the solution goes in the box, so this would be 2, right? And then I'm going to put the coefficients next to it and do a little synthetic division. So I'm going to break down the 1. We'll multiply 2 times 1 and get 2. Add 6 and 2 and get 8. Multiply is 16. Add is 15. And 2 times 15 is 30. We get a remainder of 0, which is what we should get, seeing how it said that x minus 2 was a factor, right? If I know it's a factor, then I should get 0, correct? Right? So then the remaining polynomial is x squared plus 8x plus 15. If I were to factor that, hopefully all of you find that relatively easy. So the factors there would be x plus 5, x plus 3. All right. I'm going to ask you guys to do the second one here by yourselves. Again, it's on Edpuzzle. So you're going to type in your answer. After you type in your answer, the entire worked out explanation and everything will be there for you. But I want to see what you guys can come up with by yourself and then type that answer into Edpuzzle. All right, here we go. Hopefully you guys put in 2x plus 3, x plus 1 into the Edpuzzle. I'll be checking that. But here's a really quick explanation as to what you should have done. So we know that x minus 2 and x plus 3 are factors, right? So again, I'm going to relate this to numbers, okay? If I know that 3 and 2 are factors of 72, okay? So again, this is exactly the same thing. We know that 3 and 2 are factors of 72. Well, what are we going to do, right? If we want to find the remaining factors, first, we're going to divide 72 by 3, right? So if I did that, I would get what? 2, 6, 24, right? And the remainder is 0. Now, that should make sense, right? Because we divided by 2, and I know that 2 is a factor based on that, correct? Well, when I divided it, did the remainder become 0? It did, right? Okay, now, next thing. We know that, in this case, we didn't use 2, okay? So we know that 2 is also a factor of 72. Do we need to divide 72 by 2 or divide 24 by 2, correct? Does that make sense? Because we still haven't gotten the factor of 2 out of 72 to continue to factor it, correct? So I can divide 24 by 2, and that is 12 again, right? And I again get a remainder of 0. So now this number is the only number that I have to factor. And that's exactly what I did in this case, right? After I divided those and I got a remainder of 0, here's the polynomial I'm left with after I got rid of this factor, right? So that means that I only got rid of this factor. So this factor of x plus 3 is still inside of that polynomial, or is still inside of that number in the case of 72. Does everybody understand that, right? So here I divided 3 out of 72, and I got 24, yes? Right? That still means that the factor of 2 is still inside of 24, right? All I did is take out the 3 from 72. Does that make sense? So I'm going to divide the 2 then out of 24. Same thing here. I'm going to take my new polynomial and then divide the factor of x plus 3 out of it. And that's exactly what I did here, right? So you have negative 3 I'm dividing that, and 2, 11, 18, and 9 are the coefficients of my new polynomial, okay? I divided that out. I'm left with this, and this thing that I just circled in blue is a quadratic, and can we factor a quadratic? Yes, we can, right? Does that make sense? So we factor that out, and we are good to go.